Myself, M. Banu Prasad, working as Assistant Professor in Department of Mechanical Engineering in MBR College of Engineering and Technology. Today, our topic is numerical control system. What is our previous lecture means? So, definition of numerical control system, principle and operation of numerical control system, and next one is NC modes. So, what are the NC modes? Means first one is program of instruction. First one. So, second one is so mission control unit MCU. So third mode is NC mission tool. Fourth one is NC cutting tools. These are the NC modes. These are our previous lecture. So comes to today topic one. So today topic is numerical control modes one. So numerical control modes. See here, these are the NC modes. So previous class one, NC modes are generally four types. One step by step one. That is modes. That is nothing but program functioning modes one. So comes to the here numerical control modes. These are the control modes one. See here, first one is straight cut mode one. So countering cut mode one. Third one is point to point cut modes one. So these are the three types of NC modes. So by the cutting tools one, cutting onwards. So by cutting onwards, we have the three types of NC mode. First one is point to point cut one, straight cut mode, countering cut mode. So these are the modes one. First one is see here point to point cut mode one. So numerical control modes one. The first one is point to point cut mode one. So see here it is used to move the cutting to predefined position one. It is used to move the cutting tool to a predefined position one. So we can arrange the tool in predefined position one. So second point is the mission operation is performed at the position one. The mission operation is performed at the position. So based on the position also we can set the position. That is the point meaning here. So second, third one is the speed or tool path is not important in this mode one. So the speed or tool path is not important for this modes one. So examples, what are the point to point cut modes one? Example is NC drilling mission. NC drilling mission is the best example for the point to point NC modes one. So see here, it is a PTP NC modes one. See here, it is a point to point cut one. So these are the point. So see here, it is a starting point one. So next point one, next point, next point, next point. These are point to point cut one. So these are the symbols. These symbols, it is the points. This point to point, the cut is done on the numerical control modes one. So it is the first one, point to point NC modes one. So second one is straight cut mode. Straight cut mode one. In this mode, the cutting tool is moved parallel to the one of the major axes X or Y at a control rate as shown in the figure 4.1. So best example for the straight cut modes are pocket milling. Pocket milling is the best example for the straight cut NC modes one. So see the block diagram for the straight cut NC modes. So see here. So in this one, in this mode, the cutting tool is moved parallel to one of the major axis. It moves for only any one axis, nothing but that. So that's why it is a straight cut mode. So the major axis move for X direction or Y direction. So Y direction onwards cut the tool path tool or Y direction onwards to cut the tool one. So any one direction to cut the tool one. So that is the mode one, straight cut mode one. See here, this is the starting point. We can cut the tool for X direction. So this is the straight point one, starting point one, tool, it is tool point. This is the straight cut one for X axis one. So we want to go for Y axis means see here, this is the starting point one, tool one, it is the tool point one. Maybe any one direction onwards it cut the tool one. So that is nothing but straight cut NC modes. Best example is pocket milling. Next one is third one is countering cut NC modes. Countering cut NC modes. See here in this mode, the cutting tool motion is more than one axis. The cutting tool motion is more than one axis. So and it is controlled continuously and simultaneously as shown in figure. It is controlled continuously and simultaneously as shown in figure. It is the countering NC mode. Some see here more than one axis onwards. It cut the tool one. So that is countering cut NC modes one. So see here, this modes facilities two or three dimensional profiles to be counter missioned. So in this mode facilities two or three dimensions profiles to be counter missioned. So two or three dimensions. So see here, two or three dimensions means X direction, Y direction we have. So in direction also 2 or 3 dimension profiles to be counter missioned. So that's why we can call as it is a counter cut NC modes one. So we can use the countering and cut NC missions in maintaining turning and grinding missions. So majorly countering cut NC modes where we can use means maintaining turning and grinding purpose we can use this type of cutting modes one. So these are the NC modes. In cutting one we have the 3 types of modes. The first one is point to cut one, second one is straight cut one, third one is counting cut NC modes. Comes to the next topic one. So numerical control advantages. So these are what are the advantages. Your previous class onwards you are discussing about numerical control. So introduction about the numerical control. So general principle and operation of numerical control one. So NC modes, cutting on NC modes. So these are the numerical control one. Numerical control is nothing but, so there is no computer involvement here. Directly manpower, we are operating the total machinery and doing the work. So that's why it is a numerical control one. So numerical control. So what are the advantages of the numerical control? By man operating the machine one and doing the work. So what are the advantages about the numerical control? Numerical control means, see here, the first one is comparing the conventional missions. Comparing with the conventional missions, NC mission to have many advantages. They are listed below. The first one is close tolerance can be maintained on the production. The first point for NC control missions means to maintain close tolerance can be maintained on the product one. That is the first one. Second one is parts can be produced more accurately. Parts can be produced. So it is where we can use this type of machinery. Means big mass industries, some production industries, we can use this type of machineries, numerical control machines. So numerical control machines and CNC control machines we have. So these are used in automobile industries. We can use it. So generally automobile, navy, so navy space, aeroplanes, manufacturing purposes. So and comes to the last one is mass production purpose. You can use this type of machineries. So see here, so that's why parts can be produced more accurately. It can be produced. Parts can be produced in small batches. So parts can be processed in small batches. So they divided into the production ones. They were divided into batches. So they divide into batches means small batches, big batches. Based on the production, they were divided the batches one. So the parts can be it can be produced for small batches one. That is the main reason here. Cutting tool can be used at optimum speed and feeds one. Cutting tool can be used at optimum speed and feeds one. That is the point one. So the inventory is reduced. The inventory is reduced due to shorter lead times and fewer setups. So that is inventory is reduced. So that is one of the advantages also. Next one is initial cost is very high. So why? Because it is a total mission operating system. So that's why the cost is more one compared to other production one. So compared to other production is nothing but we have the casting productions. So that compared to that production one, so it is a very high cost one. So NC missions require path programmer. So NC missions also required for path programmer. Programmer means nothing but they give the some instructions. So we have the modes one. So first one is program of the instruction. First of all, we can give the some instructions on the program one. After then we send to the mission control unit one. The mission control unit one will receive the program one. Automatically it convert to the mechanical mechanism one. The instruction seed is converted into the mechanical mechanism. After then we send to the NC machine tool. After then we send to the NC cutting tool. The cutting tool will complete the total work one and produce the output to the outside one. So this is the step-by-step modes one. So NC missions required for path programmers. There is a problem of finding, hearing, and training the programmers. So there is a problem of finding the programmer. They give the training. Why? Because they need to find the problems and hearing and training of the programmers. So that is the point one. Next one is the maintenance cost is high on the account of its complex and sophisticated technology. Why? Because the maintenance cost also very high. Why? Because so that is the technology. So the technology purpose, the cost is very high. So these are the advantages of the numerical control system. So it is the NC missions overall one. So next topic is see go to the another topic one, computer numerical control system. computer numerical control system. So see here, computer numerical control introduction. The benefits of a computer numerical machineries are directly related to its accuracy, speed, and degree of automation. So that is the main benefit of the computer numerical systems. One, computer control machines are directly related to its accuracy, speed, and degree of automation one. So that's why it is the benefit one. These are the benefits. So accuracy, speed, and degree of the automation, that is the benefit about the CNC one directly. So these demands impose design problems, and these demands impose design problems. So we can think the major problem is in this one. So that is the programmer. The design consideration should handle like vibrations, elastic deformation, backlash, extras. The design consideration should handle like vibrations. The handle, the design consideration, how can they handle means so like vibrations, elastic deformation, backlash, extras. These are the design consideration one. So next one is by comparing the conventional numerical control machines with the computer numerical machines. So these are machineries are very stronger, stiffer, and perform more accurately compared to the conventional numerical control systems with computer numerical control machines. These machines is nothing but CNC machines. CNC machines are very shorter, very stronger. Sorry, very stronger, stiffer, and perform more accurately. So more accuracy also. So compared to conventional numerical machines. So these are the benefit for the we can use it for CNC machines. So very stronger, stiffer, and perform more accurately. So these are the benefits. So it is the introduction about the CNC machines. So see here another point one, structure of CNC machine tools. What are the general structure about the CNC machine tools? Means see here the general creations for the design of structures for NC machine tools is to provide advocate static stiffness with the best stiffness to the weight ratio for a wide range of loading condition one. So general creation for the design of structure of the NC machine tool is, so the design structure for CNC machine tool is to provide adequate static stiffness, is to provide, it's provide the CNC machines. So it's provide the static stiffness with the best stiffness to weight ratio for the wide range of the loading condition. Wide range of the loading condition, loading condition onwards, it's performed like this static stiffness with the best stiffness to weight ratio for a wide range of the loading condition. So next see here another point one, in CNC machine tools, the large static stiffness allows a small deflection. So in CNC machine tool, large static stiffness allows a small deflection. It will be allowed one. So next point one, the dynamic response of the CNC machine is directly related to the stiffness to the weight ratio. So the dynamic response means the total response, dynamic response for the CNC machine is directly related. It's not for indirect one. Directly it is related to the stiffness to weight ratio. So next point is vibrating resulting from the two chatter can influence the surface finish of the products. So vibration results from the tool chatter vibrations. We have we can do the work one automatically. What happens? Some vibration onwards. Why means it is heavy machinery. We can do the work for the tool one. So automatically what happens? The vibration will be produced by the machine one. So automatically the vibration resulting from the tool chatter can influence the surface finish of the products one. So it influence the surface finish of the products one. So the next point one, the structure of CNC machine tools are cast iron based for damming vibrations. The structure of CNC machine tools are cast iron based for damming vibrations one. To achieve the best stiffness to weight ratio one, the structure are provided with the ribs one. So these are the structure of the CNC machine tools one. So see here another one, structure of the CNC machine tools, the design pattern that are to be considered along with the operating conditions are, first one is mission response. Second one is component characteristics. Third one is operating and cost characteristics. So these are the design pattern that to be considered along with the operating conditions. By operating conditions, These are the design patterns. First one is mission response. So mission response are very, very important. Fast response, quick response. After then only the product will be complete within time. So the missionary is not responding well. What happen? The completion of the work is due to some delay one. So take the more time, nothing but. So machine is reaction is respond is fast one automatically, the production is go for very fastly one. So within the time the production will be completed, again they start for the new production one. That is a main benefit for the mission response one. The what are the mission response means, see here. First one is input configuration one. Input is the main one. So you can give the input automatically, what happen, the machine will be respond for the input one. So that is the first one. It is a static accuracy. Second one, so accuracy also very important one. So so third one is magnitude of the load. Magnitude of load also very important one. Power source. Next one is type of command signals. Type of command. So we have the command. So the command signals also very important one. So next one is component characteristics. Component characteristics. In component characteristics, what we need means, first one is power requirement one. So first one is power requirement one. Second one is inertia, inertia. So third one is amount of backlash. So fourth one is bandwidth. Fourth one is stiffness. So these are the requirement for the component characteristics one. So next one is operating and cost characteristics. So operating how and cost characteristics. So what are the important means in this operating and cost characteristics means, see here. So first one is maintainability. Maintainability is very important one. That is the first point here in this operating and cost characteristics one. Second one is reliability. So that is the main point here. Third one is capital investment. Investment also very important for the CNC machine tools one. So third one is cost of operation one. How much cost for the operation? That is also very important one. Next one is installation requirements one. Some example you can install for new program one. What the requirement for the CNC numerical control one? So CNC machine tools one. In CNC numerical one, so we can give the coding. So we can give the coding automatically. The machine will be move forward and backward. So turning, grinding. Next one is polishing. Everything is operating on some computer based on. We can give the numbering or lettering or so somebody symbols also. So that these based on these onwards, the machine will be moved and do the operating one. So next one, features of computer, features of CNC machines. So see here features. What are the features one? So in previous one we will discuss about the what is CNC machines, advantage of CNC machine, or structure of CNC machine tools one. So comes to the futures. Futures mean totally nowadays the technology will be improving one. So automatically what are the some futures for the CNC machines means, see here CNC machine tools futures. Tools future one. The first one is automatic work part positioning one. First one is automatic work part positioning one. That is the first feature for the CNC machine tools one. So automatic work part positioning means, see here, to access four surface of the part, to access four surface of the parts. So most of the machining centers have the capability to rotate. So some example, four centers we can choose one automatically. Some machineries have that capability to rotate the surface of the part one. That is the first point one. That is the main point one. The job related to the spindle one. The job related to the spindle one, thereby permitting the cutting tool, thereby permitting the cutting tool. That is the automatic work path positioning one. So automatic work path positioning means, some example one, we can take the one tool, one object. That object one we can choose the work path positioning for positioning. So positions onwards we can drill. Some example ఎలా అంటే మనకు క్లియర్ చెప్తున్నారు చూడండి అమ్మ. ఏదో ఒక పార్ట్ తీసుకోండి, ఏదైనా సరే ఒక ఐరన్ పార్ట్, ఒక బాడీని తీసుకొని సిఎన్సిలో సెట్ చేసి ఫోర్ పొజిషన్స్ ఇవ్వండి. ఫోర్ పొజిషన్స్ దగ్గర మనం డ్రిల్లింగ్ చేయాలనుకోండి. సో ఆటోమేటిక్ ఏమవుతుందంటే ఆటోమేటిక్ గా ఈ ఆటోమేటిక్ ఫీచర్ ఉంటే ఆ మిషన్స్ ఆటోమేటిక్ ఏమవుతుందంటే ఆ ఫోర్ సర్ఫేసెస్ దగ్గర ఆటోమేటిక్ ఇది ఏమవుతుందంటే రొటేట్ అయ్యి డ్రిల్లింగ్ అనేది కంప్లీట్ చేస్తూ ఉంటుంది. సో సమ్ ఎగ్జాంపుల్ ఏంటి, మనకి ఆ ఫీచర్స్ లేకపోతే ఏమవుతుందంటే 4 పొజిషన్ మనం సెట్ చేసిన, సో 4 పొజిషన్ దగ్గర అది రొటేట్ అవ్వలేదు. ఎందుకు అవ్వలేదు అంటే 4 పొజిషన్ వీ హ్యావ్ ఓన్లీ 1 స్పిండిల్ ఓన్లీ, 1 tool only. So 1 tool onwards it do for one work only. So that is the main reason here. So next one is automatic tool changing capability. Automatic tool changing capability. Features of second one is features of CNC machine tool. Second one is automatic tool change capability one. So see here, a variety of machining operation one means that the variety of tool is required. So variety of machine operations, they need a variety tool is required one. Why? Because variety operation one, variety tool is required. That is the common one. So next one is the tool are contained in a tool magazine or drum one. The tool are contained in a tool magazine or drum one. So it is a drum. So see here, the tool are contained in a tool magazine or drum one. So it containing like this. So when a tool needs to be changed, some example one, when tool is need to change the operation one, automatically what happen, the tool drum rotates to the proper position. The tool drum rotates proper position one, and the automatic tool changing mechanisms, automatic tool change mechanism operating under program control one. So when the tool is need to be changed, automatically what happen, the drum also moves from proper position one. After then automatic tool changing mechanism operate the under program control one. So that is the automatic tool changing capability. How they are changing the tool means automatically, this is the main definition one. To exchange the tool in the spindle and the tool in the drum one. Exchange as the tool in the spindle and the tool in the drum one. So the tool drum will exchange the tool in the spindle one. So it is the automatic tool changing capability. It is the one of the very important one. First one is automatic work path positioning. Automatic work path positioning, first one. Second one is automatic tool changing capability one. So third one is features of CNC turning centers. Turning centers. See here, the cylindrical shapes products can be produced with the help of CNC lathes. So ఏదైనా సరే ఒక cylindrical shapes we can produce the machinery, we can help the CNC lathes one. By we can produce it also CNC lathes one. So in the industry, the majority of the components machineries are in the cylindrical shapes one. The industry, the majority of the component machines are in the cylindrical shapes only. So hence CNC lathes are also called as the turning centers. CNC lathes also we can call as the turning centers. So that is the futures of CNC turning centers. This is the futures of CNC turning center. See here, it is a block diagram for the CNC turning center. You can see this one in industries. So mass production industries, big industries, we can see this type of CNC turning centers. So it is a centers. So it is a one. So next one is, see here, features of CNC turning centers one. So turning centers and what's features of CNC turning centers one. See here, tool to write. Tool to write means nothing but it is the tool one. Tool to write one. So see here, most of the turning centers are provided with a tool to write, which many have a capacity of 8 to 12 tools of various types one. So how many we have? How many types of tool to write we have? 8 to 12 types of various types. The capacity is how much? 8 to 12 only. So in the tool turret, this one. So based on this tool turret is not what this tool turret onwards. So we can set the tool on, after then only we can start for cutting, drilling, grinding, polishing. Everything is operation is done on this tool turret only. Tool turret are very important. The most of the turning centers are providing with a tool turret with the with which may have a capacity of 8 to 12 tools for the various types. So 8 to 12 tools we have. That is the point one. That is one of the features of CNC turning centers one. See here, another one is features of CNC turning centers. Features of CNC turning centers. See here, multiple axis turning centers. So we have the CNC turning center, but we have the multiple, not for one word, multiple axis turning centers. Multiple axis turning centers means, some example one. So we have only one axis turning centers one. So presently, but on futures, what we are doing in future, some advantages in future technology means we have the multiple axis turning centers. Multiple axis means these turning centers move from X direction, Y direction, and Z direction also. Based on these three direction onwards, you can do the operation. So it cut the operation, it drill the operation, it grind the operation. So the total the work is done on three directions one. So some example one, the work we can cut on y direction, automatically turning centers will change for y direction. So the automatically the work operation is done on z direction, automatically the machine also change it for automatically the mission turn for z direction. So axis turning centers, see here these are the axis turning centers. So x y z, so these are the centers, multiple axis turning centers. These are the CNC turning centers. It is the axis turning centers. So see here a large number of axes is provided in additional to x and z axis of turning. So a large number of axes is providing in addition to the x and z. X and z direction onwards, x z axis of the turning onwards, it is providing one. The turning centers are available at z and x and c axis of the operations. So see here the turning centers area is available. The turning centers area is available on so z x and c axis of the operations. So the turning centers areas is available. The turning centers areas are available in three axes. That one is x, z, and c. So that is the point one. The main spindle holding the workpiece. The main spindle we have the spindle based on the tool will be setting. So the main spindle holding the workpiece which can be indexed to get the variety of the profile. This is called as the c-axis. What is the mean by c-axis? Means see here the main spindle holding the workpiece. The main spindle hold the workpiece one. The spindle hold the workpiece one. Automatically what happen? Which can be indicated to get a variety of the profile. This is called as the to get a variety of the profile. This is called as the c-axis one. C-axis one. C-axis. So these are the one of the feature for multi-axis turning centers. So see another one, multiple spindle turning centers. Multiple spindle. So previous class is multiple axis turning centers. So this one is multiple spindle turning center. Spindle, it is the spindle. So this one we can call as now spindles. So see here multiple spindle turning centers means it is necessary to incorporate multiple spindles for the large volume productions of small and medium sized components. So small and medium sized components man manufacturing చేయడం కోసం large production లో we can use it for, so it is necessary for multiple spindle turning centers. సో మనం ఏం ప్రొడ్యూస్ చేయడానికి బై లార్జ్ ప్రొడక్షన్ వాల్యూమ్ ఆఫ్ స్మాల్ అండ్ మీడియం సైజ్ కాంపోనెంట్స్. స్మాల్ అండ్ మీడియం సైజ్ కాంపోనెంట్స్ మనం ప్రొడ్యూస్ చేయాలంటే మషన్ షుడ్ ఇట్ ఈస్ నెసరీ, విచ్ ఈస్ నెసరీ మల్టిపుల్ స్పిన్డిల్ టర్నింగ్ సెంటర్స్ ఆర్ నెసరీ. సో చూడండి అమ్మా, సో మన మాస్ ప్రొడక్షన్ ఉంటుంది, లార్జ్ వాల్యూమ్ ప్రొడక్షన్స్ అంటే చూడండి హెవీ మిషనరీస్. సమ్ ఎగ్జాంపుల్ వన్, సో మన ఇండస్ట్రీస్ లో యూజ్ చేసుకునేది మనం ఎలా అంటే ఇప్పుడు ఐరన్ ఇండస్ట్రీస్ లో కానీ మన ఏదైనా సరే ఇండస్ట్రీ, సిమెంట్ ఇండస్ట్రీ కానీ, పవర్ ఇండస్ట్రీస్ కానీ, జనరల్ ఇండస్ట్రీ కానీ, ఏదైనా సరే ప్రొడక్షన్ ఇండస్ట్రీ కానీ, ఆ మిషనరీస్ మొత్తం కూడా దాంట్లో ఉన్న పార్ట్స్ కూడా మ్యానుఫ్యాక్చరింగ్ చేయాలంటే మషిన్స్ వీ కెన్ గో ఫర్ సిఎన్సి మిషన్స్ ఓన్లీ. కాస్టింగ్ ప్రొడక్షన్ ద్వారా మనం ఓన్లీ పార్ట్స్ కొన్ని వరకు మ్యానుఫ్యాక్చరింగ్ చేయగలుగుతాం, మిషనరీస్ ద్వారా కొన్నే చేయగలుగుతాం. బట్ టోటల్ వర్క్ మనం కొన్ని చేయాలంటే మషిన్స్ వీ కెన్ గో ఫర్ సిఎన్సి అండ్ ఎన్సి machine tools one. So machine technology onwards, after that only it is possible to produce small and medium sized components. So the twin spindle turning center as shown in figure in clearly. So it is a twin spindle turning centers. Twin and is nothing but two twin spindle turning centers. These two one we have. So in case two spindles are turrets and control separately, so we have the two spindles we can use it for two tools one, and two operations is done on this machinery simultaneously, two operations. Why? Because so it is a small and medium sized components manufacturing purpose, we can use this type of technology, multi spindle turning centers, that one. So in this case two spindles are turrets are controlled separately one. These in the first one is first turret, second turret, both operations are done on separately one. For every component two setups are possible. Every component's machine should two setups. So two setups is mandatory one, two setups are possible one. So the component can be transferred to the right spindle. The machinery is completed on the left spindle one. See here the component can be transferred to the right spindle. So the component is left, it is a right one. So the component can be transferred for the right spindle one. If the matching is completed on the left spindle, the matching is completed on the left spindle one. So it is the one of the future about the multi spindle turning centers. Multi spindle turning centers. So see here, and the last one is so CNC vertical turning centers. So see here features of CNC turning centers in this one. So CNC vertical turning centers, spindle in vertical direction one. So see here vertical turning centers means these are used when the large diameter of components on the horizontal turning centers. సో చూడండి అమ్మ మనకు వర్టికల్ టర్నింగ్ సెంటర్స్ ఉంటాయి, హారిజంటల్ ఉంటుంది. సో మనం ప్రీవియస్ చూసాం, ఇట్ ఈస్ నథింగ్ బట్ హారిజంటల్ టర్నింగ్ మిషన్స్. సో it is a vertical turning centers. So it is a horizontal one, horizontal turning centers. It is a vertical turning center. So two one we have horizontal and vertical. It is based on the production based చేసుకొని మనం ఏం చూస్ చేసుకుంటాం అంటే వర్టికల్ హారిజంటల్ టర్నింగ్ సెంటర్స్ అనేది బేస్డ్ ఆన్ ది కాంపోనెంట్. మన కాంపోనెంట్ ఏదైతే మ్యానుఫ్యాక్చరింగ్ చేద్దాం అనుకుంటున్నాం, ఆబ్జెక్ట్ ఏదైతే మ్యానుఫ్యాక్చరింగ్ చేద్దాం అనుకుంటున్నాం, ఆబ్జెక్ట్ ని బేస్ చేసుకుని దే కెన్ చూస్ ఫర్ వర్టికల్ టర్నింగ్ సెంటర్, హారిజంటల్ టర్నింగ్ సెంటర్స్. సో అది ఎలా ఎవరి మీద బేస్ అయి ఉంటుంది, బయ్యర్. సో I am the customer. So I am the customer. I am the customer. I go to the production industry. I give the some specifications on the object one. So based on my requirements one, so they can choose the vertical or horizontal one. So see here, these are used when the large diameter components on the horizontal turning centers. So large diameter components on the horizontal centers low and machines you can use it for CNC turning centers. So it has the spindle in the vertical direction. It has the spindle in vertical direction. The total machinery is vertical only. The spindle in also vertical direction. The heavy workpiece is clamped on the horizontal chuck one. The heavy workpiece is clamped on the horizontal chuck one. So it is the one of the features of the vertical turning centers, vertical and horizontal. So it is a horizontal one. It is a horizontal mission. I am saying not for it is a multi-spindle turning center. Okay, but multi-spindles only. But I am showing in this diagram, I am showing the horizontal, but it is a horizontal mission one. It is a vertical one. It is a horizontal one. It is a vertical one. But in this topic is multi-spindle turning centers. We have multi on horizontal, multi on vertical also. We can see multi-spindle turning centers. We can see on horizontal missions and vertical missions also. So it is the today class, Amma. So what are the today class is, first of all we can see the first one is CNC modes, NC modes, sorry. So first topic is numerical control modes. So numerical control modes and cutting one is nothing but we can go for cutting, point to point cutting modes. Second one is straight cut modes, countering cut modes. These are the three types of cutting modes for the NC missions. Conventional NC missions, tools one, conventional NC mission tools. This is the point to point cut NC modes one. So it is the straight cut NC modes one. Second one is countering cut NC modes one. So next one is numerical control advantages one. So previous class we will learn about the introduction about the NC missions and conventional NC missions, principle and operations of NC missions. Next one is NC modes. So we have the four types of modes for the conventional numerical control missions. The first one is program of instruction one. Second one is mission control unit one. Third one is NC mission tool. Fourth one is NC cutting tool. So comes to here our next another topic is NC modes and cutting one. NC modes and cutting one, we have the straight cutting one, point to cut one, countering cut one. So these are the topics about the numerical control one. So what are the numerical control advantages means these are some of the advantages. So next go for CNC one. It is computer numerical control machines tools. So previous one is conventional one. It is the conventional numerical control one. It is a CNC, computer numerical control machines one. So it is the benefits between the CNC and NC machines. Introduction, this is the introduction and comparison between the NC and CNC one. So next one is the structure of CNC machine tools one. So it is the basic structure. So we can need for three types of resources. First one is mission response, component characteristics, operating and cost characteristics one. So next one is features of computer numerical control machines. Features of computer numerical control tools one. So features, these are the first one. Automatic work path positioning. First one is automatic work path positioning. Automatic ఏం చేస్తుందంటే ఆటోమేటిక్గా మనకి ఏం చేస్తుంది, వర్క్ పాత్ పొజిషనింగ్ అనేది ఇచ్చేస్తూ ఉంటుంది. దిస్ ఇస్ వన్ ఆఫ్ ద ఫీచర్ వన్. సో నెక్స్ట్ వన్ ఈస్ ఆటోమేటిక్ టూల్ చేంజింగ్ క్యాపబిలిటీ. ఆటోమేటిక్ ఏం చేస్తుందంటే వీ కెనాట్ చేంజ్ ద టూల్ ఆటోమేటిక్లీ ఇట్ సెల్ఫ్, the machine itself will change the tool one automatically based on the requirement. So in this requirement we want to change the tool one automatically itself, by itself the machine will change the tool one, not for ours. మనం చేంజ్ చేయాల్సి ఉంటుంది, ఆటోమేటిక్గా అది చేంజ్ చేసుకుంటూ ఉంటుంది. ఆటోమేటిక్ టూల్ చేంజింగ్ క్యాపబిలిటీ అమ్మ. సో నెక్స్ట్ వన్ ఈజ్ దీస్ ఆర్ ద సిఎన్సి టర్నింగ్ సెంటర్స్. సో నెక్స్ట్ వన్ is CNC turning center tool target one. So see here multiple axis turning centers one. So next one is multiple spindle turning centers one. So next one is in multiple and we have the vertical also. So these are the CNC machines one. Thank you, Amma. This is the today our class one.